What if we were asked to find the power series of a function centered at 2 if we knew that this function's power series was represented like this? And we were asked to find the integral from 2 to x. Well, first we have our f of x, so let's substitute t in for x so we have our f of t. Now, of course, we need the series here from n equals 0 to infinity. And now we're going to be taking the integral. So we take the integral from 2 to x with respect to t. So how we're going to do this is switch the bounds. So that way we have our sum out here. And then we are going to be integrating the term individually from 2 to x. Now, for almost every single function you'll deal with in Calculus 2, you can do this willy-nilly. But as you get to higher level classes, there may be situations, there are certain restrictions that allow this switching to happen, and I'd be remiss if I didn't inform you that not all the time, but you should be careful about switching this series and this integral sign. But for Calculus 2 purposes, you should be fine. Oh, just notice this is a 1. This should be a factorial. All right, so let's do this integral. So all of the factors that aren't t's can be moved. So we end up having the sum of n equals 0 to infinity of -1 to the n over 2 to the n plus 1 factorial. And then we still have our integral, though. Our integral of just now t minus 2 to the n dt. Now, how do we do this integral? We just find the antiderivative, which would be our t minus 2 all to the n plus 1 divided by n plus 1. And then we add the remaining terms. So our -1 to the n over 2n plus 1 factorial. And we still have our sum from n equals 0 to infinity. But remember, this wasn't an indefinite integral. It went from 2 to x. So we still have to evaluate this at 2 and x. But luckily, what do we have here? When we plug in x, it'll just be the same. We get the sum from n equals 0 to infinity of -1 to the n, x minus 2 to the n plus 1, all over 2n plus 1 factorial and multiplied by n plus 1. And then when we plug 2 in, we get a 2 minus 2, which is 0. So this whole term disappears. And this is just the function that remains. So the integral, the definite integral of this power series is going to be this power series